Types of resources on the basis of origin. Biotic resources. These are obtained from biosphere and have life such as human beings, flora and fauna, fisheries, livestock, etc. Abiotic resources. All those things which are composed of non-living things are called abiotic resources. For example, rocks and metals. Types of resources on the basis of exhaustibility. Renewable resources. The resources which can be renewed or reproduced by physical, chemical or mechanical processes are known as renewable or replenishable resources. For example, solar and wind energy, water, forests and wildlife, etc. Non-renewable resources. These occur over a very long geological time. Minerals and fossil fuels are examples of such resources. These resources take millions of years in their formation. Some of the resources like metals are recyclable and some like fossil fuels cannot be recycled and get exhausted with their use. Types of resources on the basis of ownership. Individual resources. These are also owned privately by individuals. Many farmers own land which is allotted to them by government against the payment of revenue. In villages, there are people with land ownership, but there are also many who are landless. urban people own plots, houses, and other property. Plantation, pasture lands, ponds, water in wells, etc. are some of the examples of resources ownership by individuals. Community-owned resources. There are resources which are accessible to all the members of the community. Village commons or grazing grounds, burial grounds, village ponds, etc. Public parks, picnic spots, playgrounds in urban areas are de facto accessible to all the people living there. National resources. Technically, all the resources belong to the nation. The country has legal power to acquire even private property for public good. You might have seen roads, canals, railways being constructed on fields owned by some individuals. Urban development authorities get empowered by the government to acquire land. All the minerals, water resources, forests, wildlife, land within the political boundaries, and oceanic area up to 12 nautical miles or 19.2 kilometers from the coast, termed as territorial water, and resources therein belong to the nation. International resources. There are international institutions which regulate some resources. The oceanic resources beyond 200 kilometers of the exclusive economic zone belong to the open ocean, and no individual country can utilize these without the concurrence of international institutions. Types of resources on the basis of the status of development. Potential resources. Resources which are found in a region but have not been utilized. For example, the western parts of India, particularly Rajasthan and Gujarat, have enormous potential for the development of wind and solar energy, but so far these have not been developed properly. Developed resources. Resources which are surveyed and their quality and quantity have been determined for utilization. The development of resources depends on technology and the level of their feasibility. Stock. Materials in the environment which have the potential to satisfy human needs, but human beings do not have the appropriate technology to access these, are included among stock. For example, water is a compound of two inflammable gases, hydrogen and oxygen, which can be used as a rich source of energy. But we do not have the required technical know-how to use them for this purpose. Hence, it can be considered as stock. Reserves are the subset of the stock which can be put into use with the help of existing technical know-how, but their use has not been started. These can be used for meeting future requirements. River water can be used for generating hydroelectric power, but presently it is being utilized only to a limited extent. Thus, the water in the dams, forests, etc. is a reserve which can be used in the future. Land resources. We live on land, we perform our economic activities on land, and we use it in different ways. Thus, land is a natural resource of utmost importance. It supports natural vegetation, wildlife, human life, economic activities, transport and communication systems. However, land is an asset of a finite magnitude. Therefore, it is important to use the available land for various purposes with careful planning. India has land under a variety of relief features, namely mountains, plateaus, plains, and islands. About 43% of the land area is plain, which provides facilities for agriculture and industry. Mountains account for 30% of the total surface area of the country and ensure perennial flow of some rivers, provide facilities for tourism and ecological aspects. About 27% of the area of the country is the plateau region. It possesses rich reserves of minerals, fossil fuels, and forests. Land utilization. Land resources are used for the following purposes: 1. Forests. 2. Land not available for cultivation. A. Barren and wasteland. B. Land put to non-agricultural uses, example, buildings, roads, factories, etc. 3. Other uncultivated land, excluding fallow land. A. Permanent pastures and grazing land. B. Land under miscellaneous tree crops, groves, not included in net sown area. C. Cultivable wasteland, or left uncultivated for more than 5 agricultural years. 4. Fallow lands. A. Current fallow, or left without cultivation for 1 or less than 1 agricultural year. B. Other than current fallow, or left uncultivated for the past 1 to 5 agricultural years. 5. Net sown area. Area sown more than once in an agricultural year plus net sown area is known as gross cropped area. Land use pattern in India. The use of land is determined both by physical factors such as topography, climate, soil types, as well as human factors such as population density, technological capability, and culture and traditions, etc. Total geographical area of India is 3.28 million square kilometers. Land use data, however, is available only for 93% of the total geographical area because the land use reporting for most of the northeast states except Assam has not been done fully. Moreover, some areas of Jammu and Kashmir occupied by Pakistan and China have also not been surveyed. The land under permanent pasture has also decreased. How are we able to feed our huge cattle population on this pasture land, and what are the consequences of it? Most of the other than the current fallow lands are either of poor quality or the cost of cultivation of such land is very high. Hence, these lands are cultivated once or twice in about 2 to 3 years, and if these are included in the net sown area, then the percentage of NSA in India comes to about 54% of the total reporting area. The pattern of net sown area varies greatly from one state to another. It is over 80% of the total area in Punjab and Haryana and less than 10% in Arunachal Pradesh, Mizoram, Manipur, and Andaman Nicobar Islands. Forest area in the country is far lower than the desired 33% of geographical area, as it was outlined in the National Forest Policy of 1952. It was considered essential for the maintenance of the ecological balance. The livelihood of millions of people who live on the fringes of these forests depends on it. Wasteland. A part of the land is termed as wasteland and land put to other non-agricultural uses. Wasteland includes rocky, arid, and desert areas, and land put to other non-agricultural uses include settlements, roads, railways, industry, etc. Continuous use of land over a long period of time without taking appropriate measures to conserve and manage it has resulted in land degradation. This in turn has serious repercussions on society and the environment. Land degradation and conservation measures. We have shared our land with the past generations and will have to do so with the future generations too. "95% of our basic needs for food, shelter, and clothing are obtained from land. Human activities have not only brought about degradation of land, but have also aggravated the pace of natural forces to cause damage to land. At present, there are about 130 million hectares of degraded land in India. Approximately 28% of it belongs to the category of forest degraded area. 56% of it is water eroded area, and the rest is affected by saline and alkaline deposits. Some human activities such as deforestation, overgrazing, mining, and quarrying too have contributed significantly in land degradation. Mining sites are abandoned after excavation work is complete, leaving deep scars and traces of overburdening. In states like Jharkhand, Chhattisgarh, Madhya Pradesh, and Orissa, deforestation due to mining have caused severe land degradation. In states like Gujarat, Rajasthan, Madhya Pradesh, and Maharashtra, overgrazing is one of the main reasons for land degradation. In the states of Punjab, Haryana, Western Uttar Pradesh, over-irrigation is responsible for land degradation due to waterlogging, leading to increase in salinity and alkalinity in the soil. The mineral processing like grinding of limestone for cement industry and calcite and soapstone for ceramic industry generate huge quantity of dust in the atmosphere. It retards the process of infiltration of water into the soil after it settles down on the land. In recent years, industrial effluents as waste have become major source of land and water pollution in many parts of the country. There are many ways to solve the problems of land degradation. Afforestation and proper management of grazing can help to some extent. Planting of shelter belts of plants, control on overgrazing, stabilization of sand dunes by growing thorny bushes are some of the methods to check land degradation. Proper management of wastelands, control of mining activities, proper discharge and disposal of industrial effluents and wastes after treatment can reduce land and water degradation in industrial and suburban areas. Soil as a resource, Part 1. Soil is the most important renewable natural resource. It is the medium of plant growth and supports different types of living organisms on the earth. The soil is a living system. It takes millions of years to form soil up to a few centimeters in depth. Relief, parent rock or bedrock, climate, vegetation and other forms of life and time are important factors in the formation of soil. Various forces of nature, such as change in temperature, actions of running water, wind and glaciers, activities of decomposers, etc., contribute to the formation of soil. Chemical and organic changes which take place in the soil are equally important. Soil also consists of organic or humus and inorganic materials. On the basis of the factors responsible for soil formation, color, thickness, texture, age, chemical and physical properties, the soils of India can be classified in different types. Classification of soils. India has varied relief features, landforms, climatic realms and vegetation types. These have contributed in the development of various types of soils. Soil as a resource, Part 2. Alluvial soils. This is the most widely spread and important soil. In fact, the entire northern plains are made of alluvial soil. These have been deposited by three important Himalayan river systems: the Indus, the Ganga, and the Brahmaputra. These soils also extend in Rajasthan and Gujarat through a narrow corridor. Alluvial soil is also found in the eastern coastal plains, particularly in the deltas of the Mahanadi, the Godavari, the Krishna, and the Kaveri rivers. The alluvial soil consists of various proportions of sand, silt, and clay. As we move inlands towards the river valleys, soil particles appear somewhat bigger in size. In the upper reaches of the river valley, that is, near the place of the break of slope, the soils are coarse. Such soils are more common in the Piedmont plains, such as Dwars, Chos, and Tarai. Apart from the size of their grains or components, soils are also described on the basis of their age. According to their age, alluvial soils can be classified as old alluvial or Bangar and new alluvial or Khadar. The Bangar soil has higher concentration of conker nodules than the Khadar. It has more fine particles and is more fertile than the Bangar. Alluvial soils as a whole are very fertile. Mostly, these soils contain adequate proportion of potash, phosphoric acid, and lime, which are ideal for the growth of sugarcane, paddy, wheat, and other cereal and pulse crops. Due to its high fertility, regions of alluvial soils are intensively cultivated and densely populated. Soils in the drier areas are more alkaline and can be productive after proper treatment and irrigation. Laterite soil. Laterite has been derived from the Latin word later, which means brick. The laterite soil develops in areas with high temperature and heavy This is the result of intense leaching due to heavy rain. Humus content of the soil is low because most of the microorganisms, particularly the decomposers like bacteria, get destroyed due to heavy temperature. Laterite soils are suitable for cultivation and adequate doses of manures and fertilizers. These soils are mainly found in Karnataka, Kerala, Tamil Nadu, Madhya Pradesh, and the hilly areas of Orissa and Assam. After adopting appropriate soil conservation techniques, particularly in the hilly areas of Karnataka, Kerala, and Tamil Nadu, this soil is very useful for growing tea and coffee. Red laterite soils in Tamil Nadu, Andhra Pradesh, and Kerala are more suitable for crops like cashew nut. Arid soils. Arid soils range from red to brown in color. They are generally sandy in texture and saline in nature. In some areas, the salt content is very high and common salt is obtained by evaporating the water. Here you can see a video showing salt formation. Due to the dry climate and high temperature, evaporation is faster and the soil lacks humus and moisture. The lower horizons of the soil are occupied by kankar because of the increasing calcium content downwards. The kankar layer formations in the bottom horizons restrict the infiltration of water. After proper irrigation, these soils become cultivable, as has been the case of Western Rajasthan. Forest soils. These soils are found in the hilly and mountainous areas where sufficient rainforests are available. The soil texture varies according to the mountain environment where they are formed. They are loamy and silty in valley sides and coarse-grained in the upper slopes. In the snow-covered areas of Himalayas, these soils experience denudation and are acidic with low humus content. The soils found in the lower part of the valleys, particularly on the river terraces and alluvial fans, are fertile.